This week, we speak with Justin Massey from Datadog about visualizing and detecting threats to your apps. In the news segment, one fuzz gets many bugs. Bluetooth pairing gets another blatantly branded blemish. Firefox sharing gets another Android accident. Web app vulns get clearly cataloged. Aerospace AppSec gets in-flight attention, and more. Stay tuned for Application Security Weekly.
This is a Security Weekly production. It's the show to learn the latest tools, techniques, and processes necessary to understand DevOps, application security, and cloud security. Your trusted source for the latest application security news. It's time for Application Security Weekly. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM.
Welcome to Application Security Weekly. This is episode 122, recorded September 21st, 2020. I'm your host, Mike Shima, and I'm here with Matt Alderman. Hello, Matt, and good morning.
Too many twos for a Monday.
Too many twos, which is a good thing that we have a third host here, which is John Kinsella.
You guys are way too chipper for a Monday.
Mostly we're just waiting to see what hardware project you'll be working on this week and putting, risking life and limb for. So hopefully it's something with a soldering iron and flame.
I'll work on that.
Perfect. While John's working on that, you can join the Security Weekly mailing list for webcast and virtual training announcements and to receive your personal invite to our Discord server. Visit securityweekly.com/subscribe and click the button to join the list. B-Sides Boston is back in action for their 10-year anniversary. The conference will be held on Saturday, September 26th, and tickets are only $10. You can get yours at bsidesbos.org. Some of the Security Weekly team will be in our own channel on the B-Sides Boston Discord server, answering questions and possibly doing some contests. Justin Massey is a product manager at Datadog. His background in managing the technical operations of an MSP led him to discovering weaknesses in many businesses, networks, and applications. After leaving the MSP, he transitioned into the role of penetration tester and application security engineer to identify the weaknesses before the attackers. Justin's current focus is building real-time threat detection products for custom applications and cloud environments. Hello, Justin. Thank you for joining us.
Thanks, Mike. Happy to be here.
And we're happy to have you here because we've been talking quite often on the show about DevOps, and one of the premises is improving engineering practices through feedback loops. One of the ways to get those feedback loops is having application logging, and application logs look at apps' performance and health. But when we add security to that equation, we might have to start thinking about different things in our application logs, or at least figure out, are our application logs sufficient? So as we put our security hats on and talk to these DevOps teams about application logging, what are some of the things that we should start considering about?
Yeah, I mean, first thing to think about is, are all the information you need in the logs. Does it include things like network IP address? Does it include usernames? Does it include the correct IP addresses? Whether they may be internal, external, upstream from like a proxy server, making sure that those are all logged for like authentication purposes, and also all the authorization things that for the applications. Whether this request was permitted or denied, and like why it may have been denied. Those are things like I immediately start to think about when I think of application logs and how it ties into security.
Yeah, so that's interesting. So already you talked a lot of very tactical, very specific things, IP addresses, the real IP addresses. And I think let's just poke around a little bit of this. Is you mentioned this list of items. Why is it that some of those might be missing from logs in general? Wouldn't they normally just be available to engineers as they're working on their applications and monitoring them anyway?
Yeah, so typically when an application goes in, if a developer wants to log a specific thing, so they want to log an action, whether it may be for an audit trail or because they're debugging something, they may write something like log.info, they're logging an informational level event, and they say, this user just logged in. Now, it doesn't mean that the user, like the actual username, is in that log. The developer may just say, user logged in, and they think that's good enough. And it may be for their purposes, for what they're troubleshooting. But the security, for that actual audit trail, you need that additional context. You need to know who, what, where. You're typically going to get, the when by default in those logs. So when you do something like a log.info, the timestamp is typically included, but all those additional attributes are not.
Yeah, but we also want to make sure that you don't put the username password in that login log either, right?
Yeah, exactly. It's really interesting because you can easily log sensitive information. You need to make sure you don't log that. So when you're logging things like say you log get parameters in an HTTP request, you may be logging sensitive items in the get parameters. Say if you were to be passing API keys over get parameters, those would be logged. So you need to make sure those are redacted. So there's this healthy balance in there somewhere.
Yeah, that's a great point. It's not just passwords or API keys, even if you're talking about just privacy related content. If you're saying that your application is well designed to encrypt full names, dates of birth, even just email addresses, but even popping it through post requests. And if all that post data is getting logged to some less secured or unencrypted data store, or data lake is perhaps one of the common parlance of the day, is that's suddenly a liability that you didn't want to have for your security. So, I guess one of the reasons we're saying we want to collect a lot of more data for security, but maybe Justin, tell us a little bit more about why we want to collect this data, or perhaps if we know how it's going to be used or how security is going to benefit from it, that's going to help inform what we should be collecting.
Yeah, so there's a couple different reasons for this. Ultimately, you look further down the road. You look in your vision. You want to do. You want to detect these threats, and then you want to take action on those. Typically, that's your goal, is to take the action, and hopefully you can get to a point where that action can be automatically taken if possible. But to get to that point, you need to take several steps back. The first thing you want to do is say, you want to visualize this data. You want to say what users are accessing my applications, what IPs. So the first thing I recommend is just making sure that you can visualize this on some sort of dashboard, so that you can see what users are accessing that application. And then there is the next step, which is the detection on it, saying that maybe this username is maybe like the domain of the email address is like a throwaway email, or the IP address is on a threat intelligence list. And then with that information, you can write a detection rule. And then from that detection rule, you can then take that further step of doing remediation, whether it's blocking this IP address in your web application firewall or doing something along those lines. But there is, you have to take baby steps in order to get there.
Yeah, and I think
Yes.
what you're laying out are some of the initial steps, because it can go a lot deeper than that. I mean, if we think about not only the login request, but also what is being done in the application. Do we see other malicious types of activities in the application that have to be correlated to the login information? I mean, you can get pretty deep from a logging perspective to really start to look at some of these potential threats.
Yeah, it's a great point. Every customer, every application is going to have their own kind of like threats to their business application. So a bank may have to worry about funds being transferred from one account to another. Another, like a shopping cart web application, may have to worry about someone changing their price of their shopping cart from $100 to $1 with a promo code or something. Every application has different things that they need to worry about, and that all has to be in the logs if you want to detect those sort of things.
And they also have to be, to Matt's point too, you also have to be decorating these requests with some type of consistent ID so that, it's not just this particular IP address. That's not going to be granular enough, I'm going to guess. But if you see here is a SQL query that was made on the back end, your ORM, how do you trace that back to what the original request was and the reason may be for forensics, for debugging, for some reason, but especially in a microservice world, how much more difficult does this type of correlation get?
Yeah, so it's not the easiest thing to do. Datadog, we have the ability to add in this trace ID that we can send from service to service, so that you can trace all the way from, the first service that gets that this variable gets injected into, and it would go downstream to the say your SQL service that's doing the SQL queries. You need to inject that, and then what happens is that when you log this info, that ID gets injected into the log so that you can trace this through all the different services. And you can think of this oftentimes. This already happens in web application flows. So you have something like an edge load balancer that then passes to, say, you have another like proxy service that then goes to the actual web application. You have typically what you may refer to as like a request ID. So you have them in your web application flow, but you also should have them in your injected into your microservices, as you mentioned, to make sure that you can track that request and see, that this specific log contains that authentication information. But then much further down the line, you have more information, that this SQL query was executed, and you can correlate back to that initial user.
So we've been talking about visualization. That was one of the things you led off with as well. But I'm going to guess, too, that we don't just visualize data to be able to say, oh, that is a pretty picture, or that belongs in a museum next to a Monet or a Van Gogh or something. So if we're visualizing data, then what's kind of the purpose of doing that? Or what should our next step be in terms of, what types of questions should we start asking of that data, or what type of insights or information should we be looking for these types of visualization to inform us about?
Yeah, so there's a couple of different things. If you can graph the data out in a very nice way for like showing events over time, you don't have to have a complex machine learning algorithm for the brain to actually detect that this is an anomaly. Our brains are really good at detecting anomalies just visually. So in the first step, you can take a look at that data and see if something looks suspicious. So if you're doing like, show me the over the course of 7 days, if you're showing all those authentication events, I keep going back to that because it's something that every single application has, or at least should have. So if you see a spike in authentication events, you may ask the question why. So that's one thing. Another thing is being able to detect when maybe an application has like a zero value. So if we are looking at those authentication events, and you go down and you look at every single one of your applications that your company has, whether they may be if they're like custom applications, you want to take a look at each one of those and say, do I actually have authentication events, or actually can I see the usernames who are accessing the application? And if the answer is no, I see zero events, then you want to ask the question why. Is it because whatever I have is broken? Is it in the log, or do I need to talk to the developers and add that information to the log? But looking for zero values is really important.
Yeah, that's interesting, because you're highlighting just as much of look at what's there as well as what's missing can be equally informative. And I'm curious, too, because that's leading to the idea of, you make a good point, just the human brain is pretty well designed to pick out these anomalies. This looks hinky, so to speak. But What do you do when you start to say, here is a signal we want to alert on and start generating alerts? And kind of where I'm thinking of, we also want to avoid the idea of just generating alert fatigue and say, sure, here are a lot of IP addresses that is a spike in authentication, but it just so happens that everybody is logging on during their lunch break, something like that, something that's explainable or not necessarily such an immediate anomaly. So how do we've got some visualization, we've got some information, we're going to start doing alerts and events, but how do we avoid that alerting fatigue for whether it's our dev side or our security side that's being responsible for responding to this?
Yeah, that's a really good point, and you need to make sure that your false positive rate isn't really high, or you are going to develop that alert fatigue. So when you're writing these detection rules out, first, take a look at that visualization. So if you're looking at a window of time, say that 7-day time frame, you need to determine whether there's going to be seasonality in there, whether it's daily or weekly seasonality, and definitely take that into account. And if whatever detection tooling you're using to detect those threats is able to take seasonality into account, then you should definitely consider that. Whether it's a daily basis or weekly basis, or whatever. We have customers who may want to look at monthly and yearly as well. So making sure that you have all that data to correctly determine the seasonality of that specific that specific login, or sorry, I guess log.
Right. Event,
right.
Yeah.
Well, especially for something like a Black Friday, right? I mean, obviously you're going to see spikes in certain activities, but that's a seasonality issue. You don't necessarily want to throw a bunch of alerts to your security team, because maybe that's just kind of the expectation because the volume's so high. So adjusting for that is I think your point, Justin. But can you roll those logs in a way that it looks at baselines on a periodic basis, but then can also adjust based on seasonality to make sure that those rules are written correctly?
It really depends on what you're using for your platform to detect those. So I think the questions and the tooling there, but you hypothetically that is possible, yes.
I guess that's a great way for us also just to touch on that idea of, do you have the data available to you, in the sense of what's your retention policy, as well as I think there's a difference between just having lots of data but having lots of structured data, or even just index data. So maybe tell us a little bit about, if we do want to detect that seasonality, whether it's weekly, monthly, even yearly, what are some things that engineering teams should be considering in terms of those practical aspects of just collecting all these logs?
Yeah. So if we look at, when you're actively investigating an event, you're probably going to want that data in some sort of like hot storage, where you can ask questions about that data really quickly. But the problem is that if we look at how long it takes to detect some of these threats from the past, or some of these compromises, it can be months and months and months. So you may not want to pay for all of that data to be in, say, hot storage, because hot storage is expensive. And what you can do is you can structure your data in a way that you can minimize your costs, so you can put them in, say, some form of cold storage. So you look at, say, something like S3, AWS S3. That storage is like cheap. I mean, it's if you even put it in Glacier, that's like even cheaper. So if you can put your data in a data store that is much cheaper, you can then say when you need that data and need to ask those questions about, like, what happened at this given point in time. If you can reload that data into some form of like hot storage at this, like a click of a button, that is really, really advantageous for you, because then you can ask all those questions about that specific thing at that given point in time. So it's finding a solution that you can balance that cost saving approach. I think I answered the question on the cost storage part. You asked a question about the the structured versus unstructured data as well, correct?
Mm-hmm.
Okay.
Yeah.
So So structured versus unstructured is very interesting because if you look at a given log line, you may have something like the user may write user Justin Massey logged in to this from IP1234 and just logged in successfully. Now, the problem with logging something like that is that you're going to have to write Grok parsers or some way to parse this data, and in order to show it in, say, a dashboard, because you're wanting to show that Justin Massey logged in from that IP1234.
Mm-hmm.
So I recommend that people look at using some sort of like semi-structured format so that they can easily parse this out. So if you say user Justin Massey, it's like putting user equals Justin Massey and then IP equals 1.2.3.4. So that you can ask questions about that, because the next thing that's going to happen is your application developers are going to go in and slightly modify that log line. Maybe user login successful, and then maybe they change it to user logged in successfully. Change that just a little bit, and it's going to mess up your Grok parser. So all of your queries that worked for in the past are no longer going to work in the future. So if you can structure your data in a way that's at least semi-structured, so you can ask questions about that data and easily parse it out, it's going to make your life a lot easier.
So you've been describing just right there that discussion of structured, unstructured, or semi-structured, even the hot versus cold storage. You're describing a lot of very, I'll say, kind of common, not necessarily basic, but engineering practices. So I'm kind of curious in terms of looking at this and improving the application logging. This seems like a very engineering, or let's just call it DevOps driven practice. How have you seen security teams kind of embrace this to start those conversations with DevOps teams to say either sort of the question of, is your application logging up to par, or we need to improve our application logging for these reasons. So I'm kind of curious who or how has that conversation been driven?
Yeah, I think it's mostly been driven. Say when you have there's two ways. Typically, it's the unfortunate circumstance that the security team gets a request or they become under attack, and they're like, we need these logs, and then the developer's like, well, we don't have these in the logs, so they find out in an aftermath situation, which is not a good case. So that's one way. Another way is that your customers, maybe your customer wants an audit trail and they want to ask those sort of questions. Show me what happened from this, from this user, or show me everything that happened in my account. And once again, the customer, you as an organization, can't answer that question. So those are like two bad ways you don't want to go about that. But some other ways that customers are going about that, finding out like proactively, is doing things like building these dashboards so that they can visualize this information, and then taking it a step further and doing, say, a tabletop exercise and saying, let's get out ahead of this. Let's get out and say what may happen in an attack. What questions are we going to want to ask? And then see if we can answer those questions. And then, like, if we can show this to the developers are going to be, much more receptive in seeing this, rather than just, you handing over a mandate that they modify the application logs to include this information, because if they don't see the why, I mean, you need to come to the table with something and give them a little bit of reasoning behind that, if that makes sense.
Yeah, that does. And I absolutely like that idea, the tabletop exercises, or those pre-mortems, if you will, as opposed to post-mortems. I'm kind of curious if you've seen some pretty informative dashboards, or if you have maybe some suggested seeds about what a good tabletop exercise might be, just so that so some org could get started in that type of practice.
Yeah. So there's a lot of different sorts of like dashboards and tabletop exercises I can think of. But first you have to figure out, what there's tabletops that are going to be coming from like your customers, and then some things that are going to be like internal. And a lot of internal things may be around like What, like they may look at more of like your cloud audit logs. So that may be like AWS CloudTrail, like what user did this? Can I answer these sort of questions, or what EC2 instance did this? Versus the customer facing ones, which are going to be what users are performing these actions. So I I would recommend just taking a look. Like I keep going back to authentication authorization. Like start building these dashboards out and start asking these questions. Like the who, what, where, when, and sometimes you can sometimes ask why. Like why did a user fail to do this? So just start asking with those very simple questions and go from there.
Yeah, that makes a lot of sense to me because I can imagine too, just for detecting credential stuffing, brute force attacks, as well as perhaps giving some information around account takeover. Maybe that's happening on a particular group of emails that you can correlate to a prior breach, something like that. So I like where you're going with that because even just focusing on authentication, I can already imagine a couple what hopefully would be interesting scenarios to bring that DevOps team into that conversation. I'm curious too to sort of then, is there also aspects, speaking of where are the zeros, and you were kind of highlighting that, where do we lack data that can be equally informative because it's just saying that either it's not relevant or we need to improve our application logging at those areas. What about types of attacks that may not be as visible in the just looking at logs? Because we have been focused on the idea of logs as a good forensics tool or logs as a good detection tool, but we want to make sure we don't, and I'll perhaps overuse this term, over-index on assuming logs can identify everything. So maybe give us an idea of what we should perhaps be considering for other tools or other techniques to use as detection capabilities for particular types of attacks.
Yeah, so we briefly mentioned earlier that you don't want to be logging sensitive data into your logs. So if you look at say an authentication form field for username and password, you're not going to log the password, so you're not going to be able to detect if there's SQL injection in the password field. So there are places like that. A lot of the OAuth's top 10 cannot be detected strictly based on logs, simply because you don't want to store all of that post body information in in uh, in the actual logs themselves. So anywhere that the OAuth top 10 interacts with those sort of sensitive data fields, you're not going to be able to detect threats on those based on your logs. You're going to have to look at a different mechanism. Maybe it's like a web application firewall that does inline inspection of it, but not actually on the raw log, because your web application firewall is going to just drop the actual data after it's parsed. It's never going to store it anywhere. It's just going to look at it, either on the host or inline in the actual request flow.
Yeah, and that's good to keep in mind. Just so as we're building up threat models, we know what's in our toolbox that we can apply for the most relevant areas. But to loop back to where then application logs might also be really helpful, I'm going to guess, or at least hope, that there's even at the application layer denial of service. So very much different than just flooding networks with tons of UDP packets, pings of death, types of attacks. At that layer 7, that's where logging and being able to trace requests back to particular request IDs can start to answer one of those questions that you brought up briefly as why might someone be doing this? And if someone is hammering a particular API endpoint, maybe that's because it's causing a full table scan or it's causing some asymmetric use of resources on the server side that's actually triggering just that, call it the availability or just the uptime. It's going to be impacting the uptime of the application, which is a very common engineering concern that also now has that Venn diagram overlap with security. So I think there's still some great effective things that we can be looking at from the application log layer.
Yeah, I agree. You made a good point about if you think of some sort of like network attacks like ping of death, a lot of those are now handled at the edge load balancer, and since that's terminating the network connection at that point, you're not going to be seeing that on your actual services and hosts that are running your application. There's, if you look at like some really interesting attacks, like to give an example, like a DNS reflection attack. Like if you could imagine that inside of an application, you can make a single request that maybe does reflection inside of your application and can take a long time to respond. Maybe it's a query that's malformed and it's going to then start consuming CPU resources that then is going to cause, your server to overload or cause other requests to start timing out. That's that's something that you may be able to look at inside of the application that is really interesting to consider.
Yeah, imagine a server-side request forgery would be another great candidate for that. Just who's abusing your app to poke around the inside of your network. And the cloud service providers, they've hardened their own internal metadata services against SSRF, but you as the app developers may still have a lot of things that are vulnerable to that.
Yeah, I mean, those cloud developers can only do so much. I mean, GCP's always had the header on there that you always have to make. So if your application is just making a single request and you don't have control of the headers, then then you're not vulnerable. But what if you do give the user control of the headers? There are business use cases for that. So being able to log this IP address 169.254 is accessing your making a request. Sorry, a user is making a request to that address. That's interesting because then you're not only is this user attacking you, but it's not an unauthenticated attack. It looks like they're actually maliciously targeting you. So being able to ask the question is is this user? This could be a couple different things. This could be like a user of an organization that's a legitimate organization, and they're maybe this user is actually compromised. This could be like some attacker who's trying to test your application to find its weaknesses. Maybe it's a part of a bug bounty program, or maybe it's another person who's actually trying to exploit your application for nefarious means. So taking it a step further and not only asking, looking at, attacks that are maybe a script kiddie would run, but very targeted attacks that you can get from those application logs by saying, this IP address 169.254 was just requested from this user is really, really interesting. And you can write detection logic on that and notify you and say that this user for this specific account is targeting your application.
Yeah, I
guess the question. Question there. Let me squeeze one in. Sorry. On that example there, Justin, does everyone have to write all these rules? And I'm not talking about specific product, right? But that's a good example. But how do you make that more general so that people don't have to go and start scribbling or trying to actually do the development on the rule to actually track that type of thing down?
Well, there's a couple of different things. If for that specific example, you can if say the user made a request directly from the application for that address, I mean, it has to be in the log somehow. It has to be. You could probably do some sort of interesting hook at the agent level and say, look at that this application is making this request for this IP address. But if you take it a layer up from actually that one, you may you see people who will set up a domain like metadata.com. And this is not a real one, metadata.com, and it will resolve to 169.254. Now, if you have access to those DNS logs and you have tooling that just says, let me know when I have let me know when a domain resolves to that that metadata IP address, you can detect that. So somehow that your product has to have whatever detection product you're using has to be able to detect that specific malicious request. So
you're thinking
I don't.
You're thinking more of the actual detection. The logic would sit in, as you say, we'll use the phrase detection product, and not so much on the logger side of things.
Yeah. So I mean, it has to be in some log somewhere to be sent to the detection product, right? I can see a world where it's a little bit different, but in the current world we live in today, where pretty much all of the security products are doing detection based on the logs, yeah, it has to be in the log somewhere.
Yeah. Yeah, I was going to go down the path of the integration of things like network data, right? When Paul and I talk about his enchanted quadrants, you've got the log data, you've got network packet data, threat intelligence, and some endpoint stuff. Those extract out into an application security world as well. I mean, we talked a little bit about, maybe it's the container is the endpoint, or the API is an endpoint in logs. Can you bring some of that network packet data in as another correlation point to the log data to look for some of those kind of network activity layers in your detection rules?
Absolutely. Yeah, so I don't think that your detection rules can probably pretty much remain the same, but the additional contextual information. So if you take a look at like a pod in a Kubernetes world, right? So you have a pod in a pod, or let's take a step back. There's a node where like the host, which is like the host of Kubernetes, and then you have pods that live in that, and you have containers that live in that. If you want to detect, say something at that, like the pod is making malicious requests to an outbound, IP address. Maybe it's like crypto mining. Well, you need to get contextual information on that, because you may have 100 pods running on that node, and if you just know that node is communicating with that malicious IP address, you need additional contextual information to know which exact pod and maybe which exact container was making that request. So you need to maybe refine your tool a little bit to give you that contextual information around what actually was happening on that given pod. I keep using the wrong word, sorry. On that node at that given point in time, if that makes sense.
Yeah. Yeah, it's understanding those different layers in a microservice-based world. And part of that is network traffic, but part of that is also internal communication from the node, the pod, the container, right? And sometimes not easily visible to get some of that data, right? To be able to extract that out, build that context, actually create the appropriate threat detection rule.
Yeah. There's knowing which pod and container that request came from, but there's also one level deeper, which is looking at which process made that request, and like what actually happened at that given point in time. That's something that we're seeing more products. I know Datadog is working on this as well, detecting it at runtime, so that you can use some sort of hook to detect this sort of thing and provide that contextual view of exactly what happened.
Yeah.
Oh, yeah, that's very cool. And so, Justin, I want to say, thank you for enlightening us, giving us insights onto the nodes and pods of Kubernetes and logging for our podcast here. Curious if there's any final thoughts you'd like to say or suggestions you'd like to make on, if you were only going to log these one or two things, what would be some good ideas to log?
Well, I think I've harped enough on authentication or authorization, so I think we can say that. There's one thing that we didn't talk about, and I'll just briefly mention. We typically talk in DevSecOps about bringing security into these things, but one thing that I think that security people need to take into consideration is giving some value back to the DevOps team. So we want to add in things like web application firewalls. We want to add in all these different runtime application security products. But measuring the latency on these products that they're adding to that you're actually impacting. If you're going to put these in line of a customer request, you're going to be slowing down the application. And we want to add those. We want to add security to DevOps, but we haven't done a really good job at, adding DevOps to our tooling. So making sure that we can do things like measuring the added latency that we're actually adding to the pipelines, I think is really important, because we like to kind of like shy away from that as a security industry and not talk about that. So I know that's kind of off tangent a little bit, but I think it's something we really need to embrace as a community and think more about.
Yeah, I think that's a great point, and a lot of it boils down to, is security adding value by asking for this data, adding to this logging, and hopefully the answer is yes. But I know that you've added a lot of value for us, just describing a lot of this information to us, and a lot of these approaches. So I want to say thanks again, Justin.
Yeah, thanks for having me. It was a pleasure.
Cool. I also want to thank Matt and John for joining us as well. If you'd like to learn more about Datadog, visit securityweekly.com/Datadog. And now I want to thank you for listening, and stick around because we're going to take a quick break and return with news of the week.